Hello everyone. Today let's solve the problem number 502 IPO. Right. So I'll just read the question loud. So just listen to this. Um, we are given n projects, right? So just give me a second. 1 second here. 1 second. Yeah. We are given n projects. So we are given n projects, each with profit of I. So each with here profit of I. So just give me a second here, each with profit of I, right? So and a required minimum capital of I, and a required minimum capital of I. So this one, let me write here, capital of I, right? So again, so we are given n projects, each with profit of I and required minimum capital I. To start with initial capital W and choose at most k projects. We have to start with initial capital W and choose at most k projects, and choose at most k projects just to maximize our final capital, right? So each time we can only pick projects that our current capital can afford. Each time we can only pick projects that our current capital can afford. Once a project is finished, its profit is added to our capital. Once a project is finished, its profit is added to our capital. What we need to do here? We need to return the minimum final capital possible after picking at most k projects. What we need to do here? We need to return the maximum final capital that is possible after picking at most k projects, right? So we're done with the question part. Right, so let me come to the first example. I'll just consider the same example for the approach. So I'll just show this one. So let's discuss the same thing for the approach. So you can just do the same thing, or you can just try it out for the same thing. Try it out for the example 2 as well. Sorry. Yeah, this is fine. So now K we have been given 2, W we have been given 0, profits we have been given here 1, 2, 3, and capital we have been given 0, 1, 1. So what is our main goal here? Our main goal is to maximize the capital after picking at most two projects, right? So our goal is to maximize the capital after picking at most two projects. Here, let's move on with the step 1. So we have to group the projects as capital I, capital of I, comma profit of I. Nothing but when we group, so this one will be 0, 1, capital I, profit of I, right? 0, 1, 1, 2, and 1, 3, right? So when we group that one, it will be quite obviously 0, 1, and this one 1, 2, 1, 3, right? So this will be 1, 2, this will be 1, 3, right? So we are done. We are done grouping the projects, right? So nothing but capital of I, comma profit of I. So this one 0, 1, 1, 2, 1, 3. So this is fine. So let's move on with the second step here. Let's sort all the projects by capital requirement, right? So we need to sort all the projects by capital this one requirement. So let's start with W equals 0. We have been given W equals 0 here. So let's start with W equals 0. Only project with capital less than or equal to 0 we have to consider. That is, we have only 0, 1 less than or equal to 0, right? So we are considering, or we are starting with W equals 0. Only project with capital that is less than or equal to 0 here is 0, 1, right? So we have to push, sorry, profit 1 to the maximum. So one more thing I didn't mention, we will be going with a maximum priority queue or the maximum heap, right? So we have to write the custom class for the maximum heaps. That is the reason we'll be going with the priority queue. Basically, I'll just call that one heap or priority queue, both are same, right? So let's push the profit 1 to the maximum priority queue, right? So we have to push the 1 to maximum priority queue. Now we have 1 within the max priority queue, right? So I'll just give here priority queue, right? So this is fine. Now let's pop the max profit from the heap or the priority queue. Let's pick one and new W, nothing but this one, new W, new value for the W will be 1, right? So new value for the W will be 1. So this is fine. Now let's go with W equals 1. Let's push the new projects, right? So let's push the new projects. Now we can consider this one, W less than or equal to 1, right? Less than or equal to 1. So this one here 1, 2, 1, 3. So 1, 1 value 1, 1 we have, right? For W less than or equal to 1. Yes, we can now go with 1, 2 and 1, 3. We can now go with 1 comma 2 and 1 comma 3. So now what we have to do, we have to push new projects 1 comma 2 and 1 comma 3 into the heap, right? So now we will push 1 comma 2 and 1 comma 3 into the heap. So the last step here would be we have to pop the max from the heap, right? So we have to pop the max from the heap, nothing but in this case maximum value from 1 2 and 1 3 is 3, right? So 1 2 and 1 3 is 3, and new w will be 4. New w will be 4 now. New w will be 4, right? So we have considered the maximum value 3, and the next value new w will be 4. So we have uh, we don't have any other this one capital of I comma profit of I. Only thing we had was 0 comma 1 1 comma 2 and 1 comma 3. We are done with solving, right? So we are done with solving. Now new w we have here is 4, nothing but the answer that we got here is 4. This we need to return as output. So w we got here is the solution that we got here is 4, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So our approach works absolutely correct in this case. Our approach works absolutely correct in this case, right? So as we are completely familiar with the approach, let's move on with the complexities part, right? So what will be the time complexity here? The time complexity would lead to big O of n log n. So we are going with the sorting, right? So this is n log n plus k log n. So this is n log n plus k log n. So this is the time complexity, right? So overall time complexity would lead to big of n log n plus k log n, because sorting takes big of n log n. As we had discussed in the approach, we are going with a sorting. So we went with a sorting basically. Sorting takes big of n log n, and pushing or popping from the heap up to k times takes big of k log n. So this takes big of k logarithmic n, right? So this takes big of k logarithmic n, right? So overall time complexity would lead to big of n log n plus k log n. This will be overall time complexity, big of n log n plus k log n, right? So this will be overall time complexity. So what would be the space complexity here? Space complexity would lead to big of n. So why it would lead to big of n? Because we have to store all the projects and heap, and also the heap, nothing but the priority queue in the first case, right? So overall space complexity would lead to big of n. This one will be space complexity would lead to big of n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n log n plus k log n and big of n respectively, right? So we are done with the code. We are done with the we are done with the complexities part, right? So now as we are completely familiar with the approach and the complexities, let's start writing the code, right? So let's start writing the code now. Yep. The first step was, accordingly with the approach, we have to store each project as a pair of capital and profit, the simple one, right? So we will be making use of the length of the profit several times in the code. So let me assign this one to the small variable, right? So that I can make use of it easily within the code. This one will be profits dot length. This is fine. The next step would be, let me go with projects. So this one would be projects. Let me assign this one to the new int of n. This one will be 2. This is fine. Now let's move on with the iteration part. So this will be for int I equals 0, I less than n. So this one will be I plus plus. So this one will be fine. So first let's move on with the we need capital as well as we need the profit as well. We need profit as well as the capital, right? So let's go with the capital that is required. So this one will be projects, projects of I 0. So this one will be equal to capital of I. So this one will be equal to capital of I. This is fine. Let's go with the profit earned. So this one will be projects of I. This is fine. 1. This is equal to profits of I. So this one will be profits of I. Right. So we are done with the coding part. So next, let's do one thing. Let's sort the projects by required capital ascending. Right. So we have seen the sorting part within the this one, right, in the approach. So let's try to implement the same. Here this would be projects comma, we are sorting, right? So this one will be a comma b, lambda expression comes here. So this one will be integer dot, let me go with a compare keyword here. So this one will be a of 0 comma, so a of 0 comma b of 0. So this is fine. Yep. Let's move on with the next step here. So let's make use of the maximum priority queue or the max heap just to pick the project with the max profit, right? Among the affordable ones that we considered. So let me go with a priority queue now. So I'll just go with, so P has to be capital, right? Priority queue. This one will be integer. This is fine. Let me consider the variable max heap. So this one will be new. Let me copy this one priority queue. This is fine, priority queue. So this one will be a comma b, b minus a. This is fine. Yeah. And now let's initialize I equals 0. So this one is 0. Next, let's do one thing. Let's move on with the next step. Nothing but let's try to pick at most k projects, right? So that's what we need to do accordingly with the approach. The fourth step. So I'll just go with while k greater than 0. This has to be greater than 0 actually. So now we can push all the affordable projects into the priority queue, right? So let me write the while loop here, while I less than n and uh, projects of I, this one 0 less than or equal to w. So this one would be, we have to push only the profit, right? So I'll just go with a max heap dot add. So this one will be projects here. This one will be I and this one will be 1. So this is fine. So we are only pushing the profit here. So let me increment the I. This is fine. Uh, let's come out of this one entirely. If no projects are affordable now, we have to break. Right. So if no projects are affordable now, then we have to break out. Right. So let me write the simple if condition. This one would be if max heap dot is empty. So this is fine. Uh, then let me go with a break statement. So this is also fine, man. So the final thing is we have to pick the most profitable project, right? So w equals w plus. So this will be max heap. So we have to pick. So I'll just go with a poll, right? So I'll go with a poll as we are making use of the priority queue. It provides poll operation, right? So this is fine. So let me go with return w. So we are done with the coding part, right? So let me format the code once. I hope this works, man. Let me hit the run button. So we are having the error here. This has to be poll, right? So poo I have given. Mm, this is fine. Let me run this one again. Yeah, we are getting the this one. The sample test cases are getting passed, right? So let me hit the submit button quickly. I hope this works for all the test cases. Let's see. Yeah, this works for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.